This is SpaceTime Series 29, Episode 82, for broadcast on the 10th of July 2026. Coming up on SpaceTime, China's Mars sample return mission set to launch in 2028. Is science wrong about our universe? And an assassin reveals its secrets. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
China says it's now planning to launch a Mars sample return mission to the Red Planet in 2 years' time, bringing back at least 500 grams of Martian regolith by 2031. Beijing says the Tianwen-3 mission is progressing at a steady pace and remains scheduled for launch around 2028. The project will involve coordinated flights using several spacecraft in order to ensure collection, orbital insertion, and secure sample return to Earth. The orbiter alone will carry 3 payloads dedicated to study Mars. There's a PEX spectrometer which will analyse potential life traces on the Red Planet and study the mineralogical composition of the surface. A molecular ion composition analyzer will study the Martian atmosphere and monitor escaping gases. And a laser heterodyne spectrometer will measure the distribution of water isotopes and dynamics in the Martian winds. The service module will integrate a Martian surface hyperspectral imager to map potential life signatures, hydrated minerals, and the identification of exploitable resources. The lander will be equipped with a laser retroreflector array in order to establish high-precision reference points on the Martian surface for advanced geodetic measurements. Beijing says with Tianwen-3, China positions itself to achieve the first Martian samples at a time when NASA and ESA's programs appear to be in limbo, hampered by technical uncertainties and budgetary constraints. This is SpaceTime. Still to come, is science wrong about our universe? And an assassin reveals its secrets. All that and more still to come on SpaceTime. Our universe should look the same in all directions, at least on large cosmic scales. But new data based on dark energy observations are suggesting otherwise. The findings are based on data from DESI, the Dark Energy Spectroscopic Instrument, which maps some 47 million galaxies across 11 billion light-years. It allowed astronomers to better evaluate the large-scale cosmic structure of the visible universe. This structure comprises strands of galaxies and galaxy clusters linked to filaments and nodes made up of superclusters, all of which surround vast empty voids, and the density pattern should be the same in all directions. But after studying the new DESI data, astronomers Francisco Salas Labini and Marco Galoppo say that's not what the DESI data has shown. Their findings, reported in the journal Nature, suggest that at the scales of a single galaxy or group of galaxies, the universe is anisotropic, meaning its structure is different depending on which direction you're looking. It turns out that in one direction there may be more voids, while in another there appear to be more galaxy clusters. The findings therefore contradict a fundamental assumption in modern cosmology, which says that at the larger scales, the universe consists of matter that is more or less distributed evenly in all directions. That's because observations based on the cosmic microwave background radiation, the leftover heat from the Big Bang 13.8 billion years ago, shows the same basic pattern density in all directions. But the new DESI data found persistent anisotropic structure in galaxy distribution out to at least megaparsec scales. That means the galaxies were clumping together more than they should in one direction, at least at scales far larger than those previously examined. These results provide direct evidence that directional coherence persists to larger scales than predicted in the standard model framework, and that challenges the assumption of large-scale isotropy. Now, the authors admit there are limitations to their study, and the universe may eventually become isotropic at even larger scales. Still, the detection of large-scale anisotropies contrasts the standard formation of the cosmological principle, which assumes statistical homogeneity and isotropy about any point. This is SpaceTime. Still to come, an assassin reveals its secrets. And later in the Science report, a new study claims taking vitamin A and D could be linked to better lung function, and in the case of vitamin D, it could help slow down your biological aging. All that and more still to come on SpaceTime. Astronomers have converted observations of a nova explosion on a distant star into sound waves in order to better understand the dynamics of this spectacular blast. A nova happens when a white dwarf star, that's the stellar corpse of a sun-like star, draws off material from a companion star in a binary system. As this material builds up on the surface of the white dwarf, it eventually reaches a critical mass, exploding in a blast called a nova. Meanwhile, the white dwarf continues to draw more material from its binary partner until eventually it triggers another nova explosion, and so the process can continue. The authors were studying nova V612 Scuti, also known as Assassin 17HX, which occurred on a white dwarf in 2017. The event occurred 9,500 light-years away in the constellation Scutum, the Shield, towards the disk of the Milky Way and near the so-called Zone of Avoidance, a region of the galaxy obscured by dense expanses of dust, gas and stars, resulting in a sort of astronomical blind spot. To understand the nova's evolution in more detail, scientists at Texas Tech University converted the nova's light curve into audio, revealing how the blast stellar shocks evolved and changed over time. The findings reported in the monthly notices of the Royal Astronomical Society are adding a new dimension to science's understanding of how the explosion unfolded. Although astronomers have long studied these explosions, recent discoveries have changed how researchers understand these events. These discoveries led astronomers to explore how novae could produce such energetic radiation. One explanation centers on shock waves. During a nova eruption, gas can be ejected at different speeds. Later, faster-moving material could collide with gas ejected earlier, in the process creating powerful shocks. These shocks also heat the surrounding gas, causing it to radiate at visible wavelengths. Recent studies have shown that much of the visible light typically observed from novae, long thought to come primarily from the nuclear reactions on the surface of the white dwarf, may instead originate, at least in part, from the shock-heated gas. To investigate the eruption, astronomers around the world who were studying the novae used spectroscopy to separate light from the eruption into different wavelengths, representing different chemical compositions, temperatures and velocities. This allows them to measure how strongly the object emits at different wavelengths and to track the motion of the gas during the explosion. The Texas Tech team used these observations to examine when the brightness jumps occurred, what caused them, and how the gas moved during the eruption. And they found evidence that new ejections occurred with each jump in the light curve. By studying shifts in the spectra, they were also able to calculate the velocity of the material. Over several months of observations, they found that the gas increased significantly in velocity with each major jump, and that's when they decided to take their analysis a step further. They had the high-resolution spectra, which measures intensity versus frequency, and they then converted this into sound pitch and frequency, providing a new view of the explosion. This report from Texas Tech University.
Have you ever wondered what a stellar explosion might sound like? In 2017, a star in the constellation Scutum erupted. Astronomers designated it V612 Scuti, a nova that didn't flare once, but several times. Novae occur when a white dwarf pulls gas from a companion star until a thermonuclear outburst ignites on its surface. The visible brightness typically surges, often by thousands of times, and then declines over weeks to months. But some novae break that pattern, flaring multiple times before fading. V612, Scuti, is one of them. Early in its eruption, V612 Scuti produced two prominent flares, each lasting over a month and brightening by roughly 15 times. Several smaller flares followed before the nova slipped behind the sun for about 100 days and later reappeared while fading. The origin of such flares remains an open question. Proposed explanations range from changes in the energy output at the white dwarf's surface to new episodes of mass ejection that drive powerful shocks. A team led by astronomers at Texas Tech University assembled an unusually dense set of high-resolution spectra capturing the eruption in exceptional detail. A spectrum spreads starlight into its component wavelengths, revealing both the chemistry of the ejecta and the velocities of the expanding gas. Comparing the nova's light curve with those spectra, the team found a striking pattern. Each flare coincides with the appearance of new spectral features at increasing velocities. In other words, faster ejections show up precisely when the nova brightens again. This can be seen clearly by creating a 2D dynamic spectral plot using the spectra, which help us to visualize the changing velocities of the gas. As time advances, new spectral features appear at higher velocities with each flare, consistent with multiple ejections. To help non-specialists experience this event in a new way, the team used these high-resolution spectra to translate them into sound by mapping the velocities to pitch and fluxes to loudness and texture. This isn't recorded audio from space, it's a sonification, a mapping from numbers to notes. When new features at faster velocity appear, we hear higher pitches and the sound's texture grows more complex, an audible counterpart to the visual changes seen in the plots. Taken together, light curve, spectra, and sound, V612 Scuti tells a coherent story. Multiple mass ejections and shock interactions likely power its multiple maxima. The timing is unmistakable. New flares and new high-velocity features arrive together. V612 Scuti is a nova we can watch in exquisite detail. And now, here.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims higher levels of vitamin A are linked to better lung function in people with asthma, while higher levels of vitamin D give similar results and could also potentially slow your biological aging. The findings, reported in the journal Thorax, examined 1,165 kids and 1,041 adults, all of whom had asthma. After measuring their levels of vitamins A and D, they assessed their lung capacity and health by getting them to exhale as much as they could in 1 second. First, they discovered that kids and adults with higher levels of vitamin A had better functioning lungs than those with lower levels. Then they noticed the same for higher levels of vitamin D in adults. And additionally, they found adults with higher levels of vitamin D also had less biological aging, that is, the deterioration of cells and tissues over time, which suggests that vitamin D may help slow aging, especially in people with asthma. Surgeons say the first ever in-human bladder transplant with a kidney has reached the promising 6-month milestone. The 8-hour operation was performed back in May 2025 on a 41-year-old man who had end-stage kidney disease and severe bladder damage. Previous bladder transplants hadn't been possible due to the complex network of blood vessels in the bladder, so surgeons had often repurposed segments of the bowel instead. In this new procedure, the donor bladder was transplanted as a true separate vascularized organ with its own blood supply, independent of the transplanted kidney. Doctors at the Ronald Reagan UCLA Medical Center say the kidney began functioning immediately when blood flow was restored, and the bladder graft also showed good blood flow and viability throughout the operation. Now, 6 months post-surgery, the patient has functioning bladder storage and is able to urinate, while his kidney remains stable and continues to function on standard immunosuppression therapy, with no signs of organ rejection. Scientists have discovered that some native grasses not only survive wildfires or bushfires, but also multiply after being burnt. The findings, reported in the Australian Journal of Botany, looked at a type of native grass known as marina. The authors had compared burnt and unburnt grasslands in central Victoria. They found that compared with unburnt grasslands, burnt areas showed increases in plant density, height and fruiting in 2 species of these native grasses. Okay guys, let's face it, as a gender, we're ugly. And now a new study, reported in the Journal of the Proceedings B, has confirmed that female faces are consistently rated as being far more attractive than those of males. The findings follow a review of data from previous studies where people rated facial attractiveness. The authors found that, unlike in many other species where males are usually more ornamental, the results show that in humans, female faces are often considered more attractive across cultures and age groups. The research shows that this gender attractiveness gap is more pronounced among female raters, with women showing an even stronger preference for female faces than men, while men tend to show more stringency with their ratings. The authors say the findings showed facial attractiveness judgments extend far beyond heterosexual mate choice. America's National UFO Reporting Center has released its list of the most popular UFO hotspots across the United States and Canada. The Skeptic's Tim Mendham says the findings were surprising, with the great state of Nevada, home of Area 51, only ranking in 19th position.
Well, there's been a lot of sightings of UFOs and UFOs viewing. And there are databases that people keep and have been keeping ever since 1947 or whenever it was that the first sightings took place. So, hundreds of thousands of sightings over the years. You may not be surprised to know that the highest percentage of sightings is in the USA. They're very sort of UFO-oriented or UAP-oriented, whatever we like to call it these days. The article came out recently looking at the figures. They had a little bit of a terminological problem with this article because it keeps referring to sightings and abductions, which of course a lot fewer people would be abducted, in quotes, than have a sighting, in quotes. The sighting is pretty common in a way. What they do say is the most common place for UFO sightings on a per capita basis is the state of Delaware. You have one reported sighting for every 928 residents. The next state in America is Washington State. The least likely place is Louisiana. You're probably having too much French food or something like that anyway. But Louisiana, in Canada, the busiest place for UFO sightings is Alberta.
Well, there's not much to do there, is there?
After that, Ontario is the biggest, the lowest, Newfoundland and Labrador. Perhaps the UFOs don't really want to go there. The interesting thing is, the really populous states, like New York State, is not that high. It's in there somewhere. And California, which you would expect a lot of UFO sightings, but it tends to be the less populated areas. And not always the Midwest areas, but a whole range of different places. Whether that says something about the people who live in those areas, I don't know. They tend to have more sightings per capita than some of the other areas. So if you want to go see a UFO, go to Delaware or Alberta. The problem is, as I said, this article flips between sightings and abductions. And I don't think there's going to be that many people abducted or claimed to have been abducted in those states. Certainly not 1 in 900 people abducted in Delaware. I think someone would have noticed.
That's the Skeptic's Tim Mendham, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.